Graph Theory Class 10 Video 1. In this video we're going to talk about colouring graphs. So let's begin with a definition. So I say that a proper colouring of a graph is an assignment of colours to the vertices so that no two vertices of the same colour are connected by an edge. So when I talk about colouring graphs, what I'm talking about is colouring in the vertices. But I don't want to colour them in any random fashion. I want to colour them in so that no two colours, no two vertices which are connected by an edge have the same colour. Or equivalently, you could say no two vertices with the same colour are connected by an edge. Okay? And we call a proper colouring with K colours a K colouring. This is just a bit of notation. Okay? So a two colouring is just a proper colouring of a graph with two colours. So let's look at an example. And let's start really simple, okay? Let's draw this graph here, which, if you recall, is the C4 cyclic graph and 4 vertices, okay? And I can colour this. I could colour this vertex green, this vertex green, and this is and the remaining two vertices I leave them blank. Okay, so blank is a color for me. So this is a proper two coloring. Okay, it's two colors, green and black, I guess. And no two green vertices are connected by an edge, and no two black vertices are connected by an edge. But if I modify this graph ever so slightly, so exactly the same thing, but now if I add this edge here, this is not a proper colouring. Okay? Because the two green vertices are connected by an edge. So that is not a proper colouring. If I wanted to find a proper colouring of the graph with the diagonal edge, so if I wanted to find a proper colouring of this graph, well, I could do this one green and maybe this one blue. Okay, this is a proper colouring. Okay, and more specifically, it's a proper three colouring. Because there are three colours, blue, green and black. Okay, obviously there's more than one way of colouring a graph. Like, I could have coloured this exact same graph completely differently. I could have done like yellow, pink, green and red. This is a perfectly good proper four colouring. Okay, it's perfectly good. It might not be like the most efficient way of colouring it. You know, we saw right here that it's actually possible to colour it with just three colours, but this down here satisfies the definition of what a proper colouring is. It's a perfectly good colouring. Okay, so we're going to be thinking about colourings for the next couple classes, and they have applications in lots of different areas. The first application I want to tell you about is to bipartite graphs. So let me state this as a theorem. And the theorem simply says a graph is bipartite if and only if it is two colorable. So this means that it's possible to properly colour it with two colours. Okay? And this theorem, it shouldn't be too much of a surprise, because if you recall, bipartite, the definition means that it's possible to partition the vertices into two disjoint sets, where all of the edges go from one set to the other set. There are no edges between vertices in either one of the partition sets. So if you just imagine colouring these different partition sets different colours, then that really highlights the relationship between this theorem and between being bipartite and being two-colorable. So let's do an example. So maybe let's start with an easy-ish example, something like this. This graph here. And if you remember this graph here, it's called C6. It's the cyclic graph on 6 vertices. Well, this graph is two-colorable. I can color the vertices like this, okay? So I have pink and black, and no pink vertex is touching another pink vertex. Like there's no edge like this, and no black vertex is touching another black vertex, okay? So by the above theorem, this graph is bipartite. Okay? And if you wanted, you could redraw this graph with 3 vertices on the left, 3 on the right. So maybe I'll put all the pink ones on the left and all the black ones on the right. Okay? And then you join up the edges, and one possible way of doing it is like this. But that's not immediately obvious. Okay, that's not immediately obvious. So using this theorem up here, it's a nice simple method to test if a graph is bipartite. This theorem helps you test if a graph is bipartite. So let's do a slightly harder example. Let's do a harder example. Okay, so if I draw this graph right here, this graph is just like a grid. Okay, and the question is this graph bipartite? Well, the way you test it is you try and find a two coloring. Is it possible to color this with 2 vertices? And is it possible to color this with 2 colors? And I think it is. No pink vertex is touching another pink vertex. No black vertex is connected to a black vertex. So it's two colorable. Thus, it is bipartite. Okay, and this would be difficult to redraw in 2 halves like this, whatever. It would be difficult to do this, so I'm not even going to attempt to do it because we don't need to do it, right? Just by finding this 2 coloring, it tells me that it's bipartite. Okay, so this is one application of graph colorings. That's the end of this example, and that's the end of this video.